Hi there and welcome. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. In this video, we will learn how to create and develop Azure Functions. This video is divided into units, and the first unit will cover what are and how to create triggers and bindings. Triggers define how a function is invoked, and each function must have exactly one trigger. Triggers are what cause a function to run. For example, in an e-commerce scenario, a new order could be the trigger that invokes a function to check inventory or process payment. Bindings are a way of declaratively connecting another resource to the function. They allow you to interact with other data sources or services without having to write the code to do so. Bindings can be connected as input bindings, output bindings, or even both. Input bindings are used to read data from an external resource, which is then available to your function. And output bindings are used to write data to an external resource, which your function can send data to. I will explain this more clearly on the whiteboard. So we just learned that each function app has one or multiple functions in it. For a function to actually do something, it needs to have a trigger. And that is exactly one trigger. It cannot have more than one. But also at the same time, if it doesn't have one, then the function will never do anything. It will just sit there. It will never be executed. What could be a trigger? A trigger could be a timer. So based on a specific time, it will be run. It could be an HTTP request where someone or something triggers that function from the outside. Or it could be an event. Let's say a file that is uploaded, for example, in a blob container, and that will trigger the function. A trigger is a specific kind of a binding, also a trigger at the same time, but it has a specific direction. And the direction for trigger is always in. That means it is a specific input binding, but also even more specific, a trigger. So let's say we have an example where we want the function to be triggered based on a file that is created in a blob container. And at the same time, we want to configure a so-called input binding so that we get further information from that file that has been created, like the length of the file, the path, or the name of that file. So we can have the trigger, the file being created, and then we want additional information that is be fed into the function and used for processing data in it. And this is what we call then an input binding. What you can also do then is you can create output bindings. Output bindings could be, for example, every time such a file information is processed, we would like to create an item in a Cosmos DB, or we would like to put a message on a queue. So every time the data is processed, we will create information in those external stores. And this is what we call an output binding, meaning the function uses this declaration to create anything in either of those. So a queue can be used, for example, to put information, a message onto the queue for other components to let them know that there's further processing needed or data ingestion, or we would like to give further information to a logic app or to an event hub to allow any further analysis or reporting other actions to happen. A function can have a third option, and that is an in-out binding. So what is this? This is just a combination of where you have the same, let's say, storage account. I have it both configured for an input and an output binding. And instead of me creating two different direction bindings, I can configure the connection string and how to interact with it in one way. So I don't have to duplicate this. And that is a specific in-out direction. The really cool thing about bindings in general is that you don't have to know how am I going to create and connect to the Cosmos DB or the queues. It is already in the framework defined. So all you need to set up is the connection string, the connection to the service, and then the functions platform knows exactly how to do the details for you. The beauty of triggers and bindings is that they let you avoid hard coding access to other services. Your function receives data from input bindings, processes it, and then outputs data through output bindings, all without needing to understand how the data is stored or how the connected services work. This makes your code cleaner, more flexible, and easier to maintain. It's one of the key advantages of using Azure Functions in your applications. Sounds too good to be true? I will show you this next, and then you will decide for yourself. In this video, I will show you how to create a trigger and output binding, also other kinds of bindings for an existing function inside a function app. So I have a couple of examples here, and I want to show you first the view from the Azure portal, just to illustrate a few things. I have a bunch of different function apps already created, and I would like to show you a particular one in here first, which is a Windows function app that hosts a function that is running the PowerShell core or running on top of PowerShell core. And when I open up the function here, there's this section functions, and I see there's one that is called HTTP example. And from in here, you just see the normal things that you have already seen before. So you already can tell by this warning or this message here, it says the app is currently in read-only mode, and that is because I have developed the function locally and then deployed it into the function app. And we know that if I do this, then I cannot change and also not read all the files directly from the Azure portal. I will continue to develop this all locally, but that is for the next demo that we're doing right now. We will just focus on triggers and functions, but that is just what this warning is all about. Now, I told you before that it's very easy to create bindings because we don't need to understand fully how to, let's say, write information from a Cosmos DB or a queue or a storage blob container, because that is already built into the functions framework. Now we really, basically what we do is we set up a connection and then we just use it in code. And this is what I'm going to show you. So this function is the basic template that is using an HTTP trigger. So I can run an HTTP request. I can call the function by that trigger, and it will run. I will show you the function in a bit. And what we will use this for is that we will not only this time print out something as an HTTP response, but we will also see a message being placed onto an Azure Queue storage. And I will show you how this output binding is defined here. So the first one is nothing new. These are both different bindings, but I want to show you the Azure Queue Storage one. If I open this up in here, you can see once it is loaded, you can see that there's not really a lot to configure here. So as a specific binding type that was added already, and then we just have to provide a few details. First is the connection to the storage account, because the queue is part of a storage account and we need to have access to the storage account. We do this by providing an access key, but all we do here is we point it to a specific setting. There's no connection string in here, and we don't want to put this into plain files, obviously. So that's really just mentioning or referencing a setting, and I will show you this in a moment as well. The other thing is we give it a name so that we know what is the identity or what is the entity that we use to write messages onto the queue. And then we just need to have a queue name that we will, again, reference inside our code to say, okay, write it to this queue, because we could have multiple queues. We could have an order queue, a products queue, a payment queue. In this example here, we just have an out queue. And this is really all you have to do. And from that point on, you can use these different parameters in code. Now you might think, okay, the portal doesn't show everything really, so there will be something more in code. Yeah, let's check. Let's have a look at our Visual Studio Code view of that project. Now here in Visual Studio Code, I have that function project loaded. We will not cover in this video how I created this. That will be the next demo, but I will show you where you will find not only the definition, but also the usage of the bindings that we just saw. So there are a couple of files that I would like to highlight in here, and I will explain them because you will see them in almost all the different frameworks and languages that you use with function apps. And let's first start with the host JSON before we look at anything else. The host JSON exists for all function apps, and it is a file that configures the function app itself. So it contains configuration options that affect all functions in a function app instance. That would be, for example, as we can see some examples about logging, configuring, enabling, or disabling application insights, providing information about existing or configured extensions, dependencies that you might want to configure. This file is always present, and you can configure this using some documented, of course, parameters for this. Another file, and you can tell that it has local prefix here. Local settings is obviously just something that we would like to know or have for local development while we are developing. This is a file that is not going into the actual file system of the function app later on. It will remain locally. How do we do this? It's just added to a git ignore file here, so this will remain local. It will remain local because it has things in here that should not be somewhere stored in a repository somewhere in plain text. It has, for example, a connection string. It has the access key. So if you remember, I showed you this in the UI, the name for the connection string that was used was Azure Web Job Storage. And that is usually, or not, this is always the default configuration value for the storage account that comes with the function app. Remember, always when you create a new function app, you get a storage account created, and this is behind that one. So this is the access key to that storage account that was created with the function app. I don't have to use this one. I can also use another one because I might want to have my queues in a different storage account. For these or simplicity here, we just have used it, but that is just another way. So if I want to use another one, just provide another value with another access key to a separate connection to a storage account. And other than this, we just have some local configuration. Once I have deployed this file is not there, so I need to provide the values for these configurations in a different way. We'll talk about that in a moment as well. So that's local settings. And what we also could do, and just let me mention this. So if you want to try out things first and you don't have a storage account already that you would like to use for placing messages on a queue, what you also can do is you can use a variable called use development storage and set it to true. And that will allow you to either use the Azure Storage Emulator that could be installed on my local machine, or the Azure storage emulation as well. So that gives you developing background, playground for storage in general that does not need to have an Azure deployment behind it. Now, I got all these information here from the function app already, and the function itself, where the actual logic is in here it's a PowerShell file. So that is the same PowerShell project I showed you in the UI before. This is the PowerShell file. Just a pretty much normal template here where we say, yeah, the function was triggered. And you can tell that it is again working with this query parameter, looking for a name, either in the request as a parameter or it's in the body. And what it does then, it will use this push output binding to write a message from that reference MSG to or the message that is the reference to the output binding, and here is the value that will be just using that name for that example here. Now, this push output binding is used to send a message to the queue referenced by that name MSG. And this push output binding commandlet is a part of the Azure Functions PowerShell worker. It's used to send data from your function to Azure Functions runtime, which then handles in the backend sending the data to the appropriate output bindings defined in your function. And that's the big question. Let us scroll down. Where is this binding defined? It's not in here, right? So you see, you can tell the name, yeah, MSG, we saw that before. But other than this, there is no definition or anything that would represent what we saw in the UI before. Where's this? You can find this in PowerShell and a few other frameworks, depending on the versions, in a function JSON. The function JSON is a file that comes with every function if function JSON is the way to define the bindings. Why do I say this? If you have C#, if you have Java, if you have Python in the model 4 version 4, then they don't use function JSON to create and configure bindings. They do this directly in code. And I will show you an example afterwards with this as well. So this file, as you can tell now, has all the bindings that we saw before in the UI. The first one is that special binding called a trigger, the HTTP trigger that we saw, with always the direction in. And then we have an HTTP out binding, and then the queue. The queue, what we say here is exactly the same configuration we had before. It just says, okay, we use this name, we use the MSG as a reference, and here is the connection. And the connection is not having that key that we provide, but it is just having that name for the configuration value that we have. Now, I want to run this function, and I will do this right directly on Azure because I have it deployed. So what I will do, I will use Visual Studio Code for this as well. So I go in here, and I have the function already open. The function app is open here. Then that's the HTTP sample example HTTP. I can right click this, and here's a function embedded. It comes with the Azure core tools that are available for Azure Functions that I can execute this. I can provide a name here. We'll just leave the default for Azure. I will just fire this up. And we should see a response coming back here saying, yeah, executed function, response, hello Azure. So yeah, the function itself worked. Now, the question is, did it do anything with a queue? So so I do this all locally right now. I use the Microsoft Azure Storage Explorer now, which I have connected to that subscription. And Contoso app BAB0 is the storage account behind my function. So if I open the queue up right now, and you see that's the name of it, then I can just tell you, okay, I left the last one in here, but this is the one where I just used Azure. And this is the message that it was now just put in the queue. Just in case that is not convincing enough, let's go ahead and clear this queue. And then I will send this one more time so you can tell that there's actually something happening. So I will execute this again. Let's just use another one here. Let's use Microsoft. The response comes back. We see, yeah, hello Microsoft, going back to the storage account. And here, let's refresh this. And there's a message now with the Microsoft on it. So yeah, so this is how we integrate an output binding. Now, of course, the question would be, yeah, but how did you get this there, right? So that is one thing. How can I add another one? So especially when I have a function JSON app in here, what I can do with Visual Studio Code, but the core tools provide a local command for this as well. You can right click it. You can on the function JSON, and then there is a setting that allows you to add a binding. If you do this, you just provide the direction that you want. Let's say this time we want to have an input binding. I do this, then I select one of the options that we have before. I give this a certain name. I use that name. Then I say what is the container or the path that I would like to use for. I could obviously use anything in here that I have, and I just provide this name. And now I need to point it to a specific connection string. So where can I find it? Since I have an already storage account, I can just do the same thing and say, yeah, you can use the same one, and we create an order container in it, and that's it. Now I have added another input binding. Sure, it doesn't do anything. My code is not doing anything with it. Now I have to implement the code that gets information from there, provided with the order, and then goes further. Okay, so that's for the PowerShell example. I want to show you one other example, and this time I chose, just to mix it up a bit, Python. Now, Python is one of those languages where if you look at this local folder structure, you won't find the function JSON. And that's not because I did something wrong. It's because you define functions, bindings and triggers different in more and more languages. It used to be just C# and Java, but now it's Python with model version 4. It's JavaScript depending on the version. So check the documentation for it. So if you don't see the function JSON, there is another way of doing it. So how does Python do it? On the right-hand side, you can see that there's the code in here. And the important part is where we have here, this line is one line that is broken down. And we use in Python a decorator or decorators to create those bindings. So it looks very similar to what we have seen before. It just provides a reference with MSG, the queue name out queue, so the same thing, and a connection, and that's it. That's how you define with the decorator like this for that method or that function HTTP example. I have this in here. And then I provide the MSG as an example, and or as an input parameter. And what I do then is, if there's a name set, we use msg.set to write the name into that queue, and that's it. So we define it in code. We don't have an extra file. Other than this, it's completely the same thing. We have a local settings JSON file in here. We have the host JSON. It's all the same thing. Of course, there are some other files depending on this and all these other that you can see here. These are Azurite because I used the storage emulator for this. These are just here because I have started this at some point. Now I can use the same function here because I have it deployed into Azure as well. So I can go ahead, find that function that I want to run here. So this is the one, Python MKE. Here's my HTTP example. I can trigger that one and execute the function now. Let's use something else. Let's say, what do we, let's say we use Alice for now. And just so that they always complete, let's do this another time and use Bob. So because there's always a message between Alice and Bob going back and forth. So we get responses here, so that's all good. Now I need to figure out what's the correct storage account to look at right now. And just to show you, so I can tell right now that Azure Web Job Service, it uses here the access key. So, and I can tell it's HTTP example test py and so on. So this is what I'm looking at. So let's go to the storage explorer, and here is our storage account. We go to the queue and we refresh this. We don't need to because it's doing us this far. And now we have these two messages with Alice and Bob. Now, Now, maybe you were thinking right now and say, Michael, you showed us the files locally, but you triggered it running on Azure. So how does it know which is the value for that storage account? Because as I said, this file, the local settings JSON, that remains locally. So where does it get this entry from? That's an easy answer, and you probably already know this. So if I go to my function app, you know that a function app has a configuration part. In that configuration, I have all the different settings here as well, because what I did in the developing phase, I downloaded all of these using the core tools, not manually or anything. I downloaded them locally. So all these values exist in the cloud as well. So this is the same account key. So when my code is running on Azure, it grabs that connection string or the access key from here and then uses it. And that is how it knows where to place that information. So hopefully that explains this a bit. And yeah, as I said, if you're interested in how did I create those locally and used a Visual Studio Code for this, I will show you this in the next upcoming demo, but we first look at some other things. In this unit, we will explore the different hosting options for your function apps in Azure. As you know, Azure Functions is a serverless compute service that lets you run event-driven code without having to worry about infrastructure. But how do you choose the right hosting plan for your function app? Well, it depends on your needs and preferences. I will describe Azure Functions hosting plan options and also how Azure Functions scale to meet business needs. Azure Functions offers 3 hosting plans: Consumption, Premium, and Dedicated. All of them are available on both Linux and Windows virtual machines. The hosting plan you choose affects how your function app scales, the resources it has access to, and the features it supports. The consumption plan is the default and most popular option. It automatically scales your functions app based on the number of incoming events, and you only pay for the compute resources you use when your functions are running. Azure Functions adds and removes instances of function hosts as needed. This is great for scenarios where you have unpredictable or bursty workloads. The Premium plan is similar to the consumption plan, but with some more extras. It uses pre-warmed workers, which means your functions are always ready to run without any delay. It also runs on more powerful instances and allows you to connect to specific virtual networks. Premium is ideal for scenarios where you need more performance, reliability, and security. The Dedicated plan is different from the other 2. It runs your function app within an app service plan, which is a fixed set of compute resources that you pay for monthly. You can manually or automatically scale your function app within the limits of your plan. This is suitable for scenarios where you have long-running or very complex workloads that require more control and customization. Besides these 3 plans, Azure Function also supports other hosting options that provide the highest level of isolation and control. App Service Environments, ASEs, the isolated dedicated plans, the Kubernetes cluster, and container apps. App Service Environment is a feature of App Service that creates a fully isolated, dedicated environment for your function app. You can let your function app run on any Kubernetes cluster, either on Azure or elsewhere. And Container Apps is a serverless platform based on Kubernetes that simplifies the deployment of containerized applications. These options are for advanced scenarios where you need to meet strict compliance or regulatory requirements, or where you want to leverage the benefits of Kubernetes. After the trigger starts function execution, the function needs to return or respond within a timeout duration. There's a certain time to it. And how many minutes this is depends on the hosting option you choose. We can configure this for all functions in a function app. This property applies specifically to function executions. But let's talk about that unlimited here. In reality, the maximum is limited by either a protocol-based request timer or by the default idle time of Azure Load Balancer, which is integrated into this service. For an HTTP-triggered function, this max value is limited to around 230 seconds. Is that too short for your use case? Chain your functions using the durable functions async pattern, for example. You will find information on how to do this on Microsoft Learn. The fundamental unit of scale for Azure Functions is the function app. Scaling affects all functions since the resources are shared amongst them. A scale controller continuously monitors event rates and dynamically deciding whether to scale out or scale in. In the consumption plan, instances can be scaled in all the way down to 0 when no requests are coming in. And when the next request arrives, we encounter cold start, the latency as the system scales from 0 to 1, ready to serve. With the premium plan, we can avoid cold starts by configuring a number of always ready and pre-warmed instances. Imagine scenarios where a downstream component, such as a database, imposes some constraints on throughput. In such cases, we can restrict the maximum number of instances a function app uses to scale out. By setting the function app scale limit value to 0, we allow unrestricted scaling. Alternatively, we can choose a value between 1 and the app's maximum capacity, and the plan's maximum needs to be taken into account too. When using an app service plan, we have the flexibility to manually scale out by adding more virtual machine instances. Additionally, we can enable autoscale, allowing the system to dynamically adjust resources based on rules we define. And to show you how powerful scaling with Azure Functions is, let me pull up a demo. In this video, I want to show you the scaling capabilities, especially of a function app that's running in that serverless mode, the consumption mode. I have a function app that's running in this mode, and it's a very simple one that uses a PowerShell core script to just greet me back with a name. So that's just a normal template. You all probably have seen this already. Now, a function app essentially under the hood is an app service, but it's a specific kind of an app service. If we scroll down here, you can see that it has information about scaling, but not in the same sense that a normal app service has. So I don't have a way of scaling up from an app service plan perspective. And that is expected because you don't have to configure this. It's coming out of the box. You don't have to create roles. If there's more load coming to your function app, it will get the necessary instances automatically without you having to interfere with this. What you can, although, do is you can enforce a certain limit and say, I would like to have a maximum of up to 200 instances. So you configure here whatever you want, because obviously the more instances you have, the more it costs. But of course, if you want to have that massive scale, even going beyond the 100 instances that we can do with the premium pricing tier, that is a really cool feature. Let me show you this in action. Now, for this function app, I have enabled application insights. What that means is I can look into the requests that are coming in and how that function as an application is utilized. For this, I will open up that Functiontoso demo application insights object. It shows me the, let's say, the current utilization of resources of that function app. This data here is not real time, so I will instead go and enable the live metrics view, which will then hook into my application at this point in time, and you can see nothing is going on. There's no request coming in, and then naturally nothing really happens. And you can tell that this indeed one server online. If I scroll down here, you can see that even at the bottom of this list, so you have indeed also a very funny server name in here, but there's nothing going on. And that instance is just there because it's very smart about this and saying, oh, Michael is around and is playing with the configuration here. So probably he wants to trigger that function very soon. So I will spin up an instance for him just in case. If I would do this now and I just leave it for half an hour, you will see it will go down to 0. I wouldn't have any instance available in the consumption model, right? So that is what we want to have. But let me show you what I have prepared. So I've used Azure Load Test, which is a testing mechanism where you can run load tests on your applications. What I will do is, while we look at that live metric view here and the list of servers online, I will run a test that will send a lot of requests to my application. It will just basically trigger this in a normal way. Now, it takes some time for this to actually come up and being executed. So it will take some time for this to show any data. But what we will eventually see is that requests are coming in, and then automatically, without any manual interaction whatsoever, or the predefined creation of rules to act on a certain CPU or memory usage, we will get additional instances. So just wait with me a bit here, and as soon as this is actually going to be executed, we will see some changes in the live metrics. Maybe while this is running, we will look into the actual test so I can also see that test has not really been started yet. There's no request still coming in. So now we see requests coming in. And my test is designed in a way that it is using a higher number of so-called virtual users to send requests simultaneously to this. And you can see in within seconds, I have 6, 7, 8 servers now online. And the CPUs in this scenario are also configured in a way that you can tell it gives over 100% CPU total. So these are specific dynamic instances that allow such a thing. And when this is necessary, it will spin up the instances that are necessary to get to a certain request operation on average. And as soon as the requests stop coming in that rate, it will then go down again. So as magically as this all appears, now that there are requests coming in, which already stopped because the test was only going on for 30 seconds, now it will take a couple of minutes before those servers or these instances are going to be deprecated. But if we will come back in 20 minutes, you will see that I will have none. And that is the sheer massive capability here when it comes to scaling with the function app serverless model.
In this unit, I will show you how to develop Azure Functions in Visual Studio Code and in the Azure portal. I will show you how to create functions within the Visual Studio Code environment and leveraging the Azure Functions core tool so I can develop this locally on my machine. And I will explain the limitations of in-portal editing. What is your favorite code editor? Mine is Visual Studio Code. By installing the Azure Functions runtime tools on my computer, I can use VS Code to develop Azure Functions just like any other project. These local environments make it a breeze to create and test functions right on your local computer. Whether you're connecting to live Azure services or debugging locally, we've got you covered. Choose your preferred language and tool, and let's explore the most effective way to develop your functions. Let's set up a function app and deploy it locally in a demo.
In this video, I will show you how to create a function locally on your machine, create a new project, test it, develop it, and then deploy it to Azure. What I do use for this is first Visual Studio Code, an editor that is free available. It's cross-platform, open source. It's a massive community behind it. It's not that you have to use it, but it makes things so much easier. And since you can use it on all platforms, I think it makes definitely a good entry point. But obviously, this is not the only way of doing this. So you can use other editors too, because how does it work? How does Visual Studio do this? First of all, there's an extension, Azure Functions, that you need to enable. If you install it into into Visual Studio Code, what it needs also, and what it will help you install if you don't have it already, are the Azure Functions core tools. That is a set of tools that you can find and freely download to get the runtime and everything that you need to locally not only develop, but also to test, to run your functions on your computer without deploying to Azure right away. And this is what you basically would need as the minimum. You could also just install the Azure Functions core tools and then work from a command line or editor of your choice that has support for those Azure Function core tools in it. But Visual Studio Code makes it super easy. Now, what I have done, or what I will do right now, you can see I don't have any files open. So I will open up the command palette. There's different ways of doing this, but you can reach this either by Control Shift and P or F1, depending on what computer operating system you are in. Then I will look for Azure Functions, and I pick that entry here, Create New Project. So if I open this up, it will ask me a bunch of questions. And that is very similar to what we have seen in the portal so far. So the first thing it asks me is, where do I want to put my stuff? So that will be just a folder, whereas I just say, hey, func dev, we will choose, let's say we choose PowerShell, because we have used this as a, let's say, common ground right now, so that nobody gets mad at me not using Java or anything other than C#. So we use PowerShell. Nobody can be mad at PowerShell, right? So I will use this. And then I get the list of different frameworks and languages that are supported. I will pick PowerShell from here. And then the list of available templates. The templates are similar, if not exactly the same what we have in the portal. But as I said, it makes a lot more sense here, since we can create even in here some that we don't see in the portal at all. And these templates come with the Azure Core Tool. So make sure that you have also the up-to-date version of it. So I could do many different things, but I will stay with the basic example. I will show you also a few more things how you can change this, but just play around with this. And there's great tutorials on Microsoft Learn where you can deep dive into each of those. So it's not just using the template and figure it out for yourself. You can just use the tutorials. So I will give this a name. Let's call it again HTTP example. That's the name of the function that I create. Then authorization level. So do I want this to be run by anyone by just having that URL? Or do I use function level where they need to have a certain key that is provided per function? For now, let's say just anonymous is good, but think about this carefully if that is what you want, right? Usually I would go for function, and that's just for demo purposes. And now it's ready to create that new project. I want to see it here, so I will just say create an open window. Now, it's using the core tools to create a bunch of files in folder structure. So on the left-hand side, you can see there's one folder that has the same name like our function. And this folder, HTTP example, has now a function JSON file, which is where we configure triggers and bindings. We have the code itself, run ts1. And there's a sample dat where it just has the sample data loaded. That is not something that we use in here. And a couple of ignore files for Git and for other things. Helpful to keep things that should not end up in a repository with some secrets in it in the repository in Azure. You know, host JSON, that is where we configure the function app itself. And then local settings JSON, where we have like the template version. Right now, there's no connection string whatsoever in here because I have started with a new template. So I don't have anything here. Now, I want to do first test if I have this code, and you already know this by now. So if I just get the terminal out of our way right now, this code really does say PowerShell has triggered this. It's looking for that name parameter. You know this already. And then it's saying, yeah, this HTTP triggered function executed successfully. And you know this, right? Let's say I will add the text here a bit so that you know that it is a different one. Welcome and hello to you. Let's say just so that we just recognize this, and that's not just a normal thing that we had before. And then in here, what we use, and we have seen this before, we use the push output binding because we just have that HTTP out binding where we say we want to respond with a response. We want to send back and response once that function was triggered. And that's all it does, right? So it either tells me, hey, provide a name, and then I will greet you very friendly with this new greeting here. And if you don't, then I just come back with this standard text. So this is what I want to do. So let's find out if that works, if that would that work in general before I deploy anything. Because at this moment, there's nothing existing for this function in Azure whatsoever. So what I want to do is I like to run this and start debugging. There are different options to do this, but let's just do it because it is already configured based on the template that I have used so that Visual Studio Code knows now what to start. It's using this func host start command line. It's a command line that is, or func is that command that is provided by the core tools. And right now it's popping up a few things. So it's getting the debugger ready. I can tell it here. So yeah, sure, there are some files that are important to add to git ignore. Yeah, that's always helpful if I ever use F#. And then if I go back here, because I'm just had another terminal open for some reason, this is the important part. You can tell here, this is the version of the core tools. And this is super important here. So it found our function by the name HTTP example. And it knows that this is now supporting get and post, and it's listening under this specific URL. So what I can do now, I can trigger that function. So I could use this and open up a browser. Let's just do this for now. And as soon as I can see where it opened up, but let's just do manually. Here it opened. Okay, now I was not fast enough. I didn't see it blinking. So yeah, that's the message coming back, right? So yeah, I can interact with this in a normal browser, but we want to do this in Visual Studio Code right now. And there's a nice integration of that as well. So with that function tool, you also can implement an Azure extension. The Azure extension will get you support for many different tasks, including managing a local functions project. So it's aware of this. It will show you this in the workspace area here in a moment. So this is where I see a local project right now. Local means it recognizes the file structure on my local machine. And on the top here, I have a connection to my subscription where I have function apps already running, sure, but none of these. So right now I couldn't run this anywhere on Azure because I need to create a function app first, right, to deploy this to. So let's do this next, because obviously my function works, and that is the reason why I went in here. So what I could also do to check this, if it's debugging, it's actually actively in debugging mode right now, I can see that it lists here the function. Otherwise, it would tell me, yeah, you need to debug this first. So I'll right click, and in here I can also say execute the function now. So it will send that request. It will ask me here. It's a little bit hard to see if you don't are not aware of this. You can just put in the name and just press enter, and that will send a request to the function. You see in the logging here that it has triggered the function again. So the logging information is in here, but Visual Studio Code also comes back with this HTTP response that we got from that function. So you can tell here, yeah, welcome and hello to you, Michael. So this is what we saw, right? And the other part that is in here, that is just the logging information, right? So this is what I have added into the file before. So yeah, other way of triggering this. Now, I would like to stop this. So I would either go and say, we could go, let's say, use the menu for this right now. I could go ahead and stop debugging. So it will stop locally. Now let's say, yeah, that looks great. I want to run this now on Azure and see if it works too. Of course it will. So you go to the workspace. You have a function symbol here on top. You click it, and then you can deploy this to a function app. Now, I don't have a function app right now where I would like to create this to. So let's just see. I think it will not ask me, or it will not give me a way to create a new one. So yeah, I will exit this. So I will first create a function app. So I can do this from here. I will give this a name. So we call it example test. This is PowerShell, and we just call it hello world. That's my example. And just to make this unique enough so that nobody stealing anyone's name. So this is the name for my function app. And now what I do from here is it will create, it will ask me the questions that I usually have to answer when I do this in the portal. So yeah, I want to have PowerShell. And then it asks me which region in Azure do I want to. So it walks me through the things, the different parameters that I have usually to fill in from the portal. This is now showing me what's going on in the backend. It's just using Azure Resource Manager to create a function app, right? And once I have a function app, I can take the code and deploy it to the function app. So get a message successfully created. It gives me the full URL also for this, but I don't need this right now. I want to deploy this. So once I have this, I can go ahead and deploy the local project. Now, once the deployment was successful, you should make sure that if you browse your subscription and look at the function app, that your new function app is actually showing up here. So, and that might take a few moments or minutes. And yeah, that's the one that we just created together here, test PS hello world. And this is the one I would like to deploy to right now. So let's go back to the local project. You select the local project, you then click on the Azure Functions icon here. And from there, you choose deploy to function app because we have now one created, right? So once I do this, I should get a drop down where I can select the test PS, hello world, and so on. And from there, it will ask me, are you sure? Because it will overwrite whatever is in that function app in the file system right now. So it's important to understand that this is a destructive process. And now let's go ahead and deploy. But since we have this developed locally, it should not really matter because you can always go back to what you have locally in place. Now, it will take a few minutes. It will zip up the files, do then a zip deployment on the app service that is underlying the function app. And once this is done, you can test the function either in the Azure portal, or we can even run it from here as well. We will do both. So I will show you how you can figure out if that is now working okay. So it says here completed, successful, awesome. You can look at the different output. You can look at the stream logs. You can look at the detailed output, so you can understand what it actually did and how that process worked and all of that. Now, first, from within the Visual Studio Code, now I'd like to try if that function works. So I will open it up from the subscription, not the local project right now, but I will open it up from the subscription. In here, I will do the same thing and I will expand the functions. There's our function HTTP example. I can right click from here and then say execute function now, and it will do the same thing as before. So let's just what didn't we have? Let's say, let's use Microsoft again, fire this up. And now it will send a request to the function app running on Azure, and it looks good. So it actually comes back with this response. Let's check this one last time, then also from the portal. So inside the Azure portal, you know that you can open up a function directly. So that is already the function app that I have open. And in here, let's refresh. We should see our HTTP example. If I open that up, you can go into code and test. Since this is now deployed from my local system, it is in read-only mode. So we cannot change it from here, but we can look at some of the files, not change them though, but you can look at the function JSON, you can look at the code itself. So one thing is you could run the test or just use a sample test from in here right away. But let's say the simplest version, and what you usually would do anyway, is you just need the URL to run. Use your tool of choice, curl, Postman. You can do this with PowerShell locally with whatever you want. So what I will click here is get the function URL. This gives me the URL for the function itself. I will paste this in here. As you can tell, this is the function app's name running on Azure Websites.net. API is always like a specific flag for all functions behind it. You can reroute this if you want, but and then after this, it comes with the name of the function. So if I run this, it will come back with our message because we have not provided a name. And you can tell here, this is the one change that I did before. Now let's provide a name. And this time, let's just use my name here. And if I do this, the function runs back. So it works. It works on Azure, definitely. Now we have developed a function locally, and we have then uploaded it, deployed it into a function app that we also created all from Visual Studio Code. Now you can go much further with this. One thing I would like you to have a look at, so that you can also find out what I did here and how do I get now bindings and triggers and all of this. The Microsoft Learn documentation for Azure Functions has great examples, and a lot of them for all different programming languages that we support. So what you would do is you have quick starts. With the quick starts, you just pick your choice, be it TypeScript or something else, Go, Rust, JavaScript. You pick whatever you want. It will walk you through to create a function app and all that is necessary from the command line or Visual Studio Code. So you have definitely an option that you can do. And once you have that function app, you can go further and say, now I would like to connect to either database or storage. And in here, it will give you then an example on how to get the function app settings using the core tool. So you have that connection string, and you know exactly what is the connection string to my storage account. It will tell you how to either use decorators or properties for the functions to set up the bindings, either in a JSON file, or for Java it is in code as well. So you provide the settings in here. It gives you example methods. Sometimes it's using the ones from the templates, but most of the time it's using this. So you can use a queue, the out queue that we saw when we created the trigger and bindings before. And that walks you through this. And it tells you also how to test this locally, how to use Storage Explorer. So all the things I did, you can look this up on Microsoft Learn, go to the quick starts, and that gives you, like I said, a playground to walk through this in your own time.
Now, let's talk about in-portal editing. Yes, you can create a function app in the Azure portal. You can create functions in it too, but only for JavaScript, PowerShell, and C# script. Our recommendation is to develop your functions locally, like I showed you. Of course, use the Azure portal to configure your functions app's settings, test it, browse through logs, and keep in mind, once you deploy code to a function app from outside the portal, any further edits to that function app's code cannot be made within the portal. It is read-only at that point. So you can only deploy this from local again. Congratulations on understanding the art of creating and deploying Azure Functions. With the ability to develop and deploy serverless functions seamlessly, you're empowered to accelerate your development cycles and scale your applications with ease. Harness the power of Azure Functions to bring your ideas to life and drive innovation in your projects. Thanks for watching. Keep on learning.